8 a.m. Saturday, March 4th. I started recording 8 a.m. March 4th. Ruler at the edge of the sun is already moved over. We're gonna see how long it takes. 8 a.m. March 4th for the shadow to cover the ruler. That's like the 3-inch mark. 4 inch, 5 inch, 6 inches. So we'll say 6 inches. Let's see how long it takes for the sun to move on March 4th in my house at 8 a.m. to cover the entire ruler. I mean, you can't really see that at some points that I'm not moving the ruler anymore. It's been a minute and it's already went 3 inches. You see how fast the sun is moving. Because I just want to prove that the sun moves at different speeds at different times of the year, which proves the flat earth theory actually. But it's been a little over a minute and 30 seconds here. We're at 4 inches. You know, it's a little fade between the sunlight. It's not like a straight line. It's like an actual little fade off. Also lets you know the sun is not 93 million miles away, because it'll be just like an even cut, but it's like a fade. It's more localized. So we're going on 2 minutes here. Let's check our clock here too. So 8:02, 2 minutes, 2 minutes video. And we're just gonna wait until the ruler is not like shiny red anymore. So basically we're at 5.5 inches now. You see the top, inches are at the top. We're at 5.5 inches, almost done. Doesn't take that long. Let's go ahead and say it. 6 inches, about now. Okay, people, this is completely crazy, but we actually don't have to wait months to prove this. Now, initially I did the experiment with the ruler. It's like 3 inches and something, 3 and something inches or whatever, like that, right? And it was from this crossing over the second square to the beginning of the third square, basically 3 inches on one side of the square. Now, over here, okay, 1, 2, 3, 4, 5, 6, beginning of the 7th, we're just gonna say, just gonna put it right here. It's already started this line. It's already started this line, but look, it took 2 minutes and 30 seconds to cover the entire ruler. So let's just start it off. It doesn't have to be in the beginning of the line. Let's just start off at the beginning of the light. It doesn't have to, we just know that 1, 2, 3, 4, 5, 6, 7. Now we're at the 7th square. And we're in my same house. The portal, I'm using my windows as my portals. But check this out. Check how long it takes to, check how long it takes for the sun to cover the ruler now. And it's 30 minutes. 30 minutes later. And we're gonna time it. We're just gonna time it. We're gonna time it starting now at a minute and 45 second mark. Okay, it's a minute 45 second mark in this video. We're going to see how long it takes the sun to cover this ruler now. I'm in my same house, okay? And I was just over there, all right? And it was like 1, 2, it was like midpoint. It was like 3 inches and 3¼ inches or 3⅓ inches or something like that. And it took 2.5 minutes. 2.5 minutes, only 2.5 minutes to cover the entire ruler, okay? But now I'm gonna show, it's gonna take much longer because now the sun is closer overhead. Okay, so basically, Let me see if I can explain this. On the flat Earth model, and I might put a diagram up in this video, the flat Earth model, the path of the sun, the way it's coming, the way the sun rotates around the North Pole. If you were standing on the ground outside, and you could actually, in the morning, the sun is coming, it's approaching, it's far away. Just say it's early in the morning, the sun comes up, when it first comes up, right? It's already been a minute, it's not even halfway there. All right, when the sun comes up, if the sun was really the one rotating around the Earth in the way that the flat Earth model says, in the morning, the angle of the sunlight would actually move faster. The sun line, we'll call it the sun line. The sun line, which marks the shadow would actually move faster early in the morning because the sun is farther away from you, okay? But as it gets closer to noon, let's just say that as it gets closer to noon, the sun line is going to slow down substantially because now the sun is right over your head and it's closer to you. So even though it's moving at the same speed, the angle of the sunlight, the speed of the sun line, let's say that, the speed of the sun line is going to slow down closer to noon because the sun is closer to you, you know? And so I'll try to say it again. In the morning time, when the sun first comes up, it's farther away. So as it approaches the sun line, it's not gonna take that long for the sun line to move because it's coming at that angle. But if the sun was overhead, it's going to take much longer for the sun line to move because the sun has already made it to you, you know. And maybe I'll try to figure out a way to better explain this. But I'm sure the Egyptians saw it too, of course, the Mayans. But the sun is localized. The sun is localized. It's only 36 minutes later, and we started at a minute and 45 second mark, and now we're at the 4 minute, 41, 42, 43, 44, 45. It's 3 minutes now. It's 3 minutes now, and the ruler has not been covered up. That lets me know that the sun has moved closer to me. If we were 93 million miles away from the sun, a 30-minute difference wouldn't make this much of a difference in time, the time it takes to cover up this ruler. I was just over there, okay? I was just over there between the second and third square. Now I'm over here at into the seventh square. That's my seventh portal over here. And we're actually going on 4 minutes now. So it took 2 minutes and 30 seconds for the ruler to be covered over there. But now over here, we're coming up on 4 minutes. You don't even have to wait. I said I was going to do this every 3 months to see how fast the sun was moving and at different parts of the year. And I still might do it. I'm still going to do it. I'm still going to do it. But this just shows we're coming up on 4 minutes. It takes 4 minutes now for the sun to cover up this ruler, and it's still not even covered. I can still see. Let me step back so you can see. You can still see the edge is lit up. So technically, from my experiment, this ruler is not covered up yet. It's almost covered up. So we're gonna go ahead and let it go ahead and get covered up and see how we can call it. If 6:05, okay. 6 minutes and 5 seconds. All right. So 5 minutes and 45 seconds, and you can tell for my phone, it's now 4 minutes left. 4 minutes. It's about to turn 8:41 here very shortly because it is closer to 5 minutes that it took. There we go. Bam. Thank you. Proof. It's closer to the 5 minute mark that it took for the sun to make it over the ruler. So it started at 1 minute and 45 seconds. So 5 minutes, 45 seconds is 4 minutes. And then if you add 20 more seconds, then you're looking at 4 minutes and 20 seconds, 4:20. So 4 minutes and 20 seconds it took to cover the ruler at the 7th square at 8:36, starting at 8:36 a.m. on March the 4th. Okay, and so over here, when I did it over here, it was only 2 minutes, 2 minutes and 30 seconds, 2 minutes and 35 seconds. So how in the world could it take the sun another 2 minutes to move the sun line, my shadow line? If the sun is 93 million miles away, how is it that much of a discrepancy on how fast the sun is moving. You know, the sun is moving from my perception. If it was so far away, it wouldn't be that different. It wouldn't be that much of a difference. It'd be like, okay, 2 minutes and 35 seconds here, and 2 minutes and 37 seconds here, maybe, or something. Maybe 3 minutes. It still doesn't make any sense. But it still doesn't make any sense for the globe theory. And so basically, if you're standing right here, okay, and I shine a light. I may make this a diagram, and I shine a light from over here, okay, and I have a light like that, and I move the light coming towards you. It's going to be faster the farther away I am for that light, but the closer I am to that light, the slower it's going to move. And so you guys can ponder on that for a minute, but it's no way that it takes 2 minutes and 30 seconds for the sun line to move over here in my second to third square. It was like in between, almost a little bit, 3 inches or whatever, 3.25 inches over. And then over here in the seventh square, 1, 2, 3, 4, 5, 6, 7, into the seventh square, it is now 4 minutes and 20 seconds it takes the sun line to cover that ruler. There's no way the sun is 93 million miles away. That's a localized sun. That means the sun is close to us because the discrepancy of time that it takes to cover the ruler is so large. It's a huge discrepancy. It shouldn't be that much difference of a time in 30 minutes. I can understand if I came back, okay, 30 days later, hey, check this out. This is 30 minutes we're talking about. This is not 3 months. This is not 3 months. This is not 30 days. This is not 3 hours in 30 minutes. It's almost double the time. Almost double the time, Double the time in 30 minutes for the sunlight to move. And I'm going to think about this just to make sure I'm not going crazy. But people, come on now, come on. There's no way the sun is 93 million miles. Where is the sunlight? It's all the way. It's all the way over. No. You know what I'm saying? But look, man. Hey, people can say what they want to say, but I see it. I mean, you can even look up the wisdom of Solomon, talking about the circuits of the sun. The circuits of the sun, not the earth. The sun is moving. Okay, the sun is localized. I mean, it's just so obvious to me now. I mean, you got to open your eyes and see. But once you start thinking about it, and once you start kind of putting your mind around it, you can kind of see it doesn't prove flat earth either way. But I'm just saying that the overwhelming flat earth evidence outweighs the globular evidence. The only thing they have is NASA's CGI photos, and I'm very convinced they're CGI photos, man, because we don't have no pictures of Earth, man. Just saying, man. Just like the Bible says. Just like the Bible says, man. The earth is fixed and immovable. The sun is moving. The rising of the sun, the rising of the moon giving her light. The wisdom of Solomon said the circuits of the sun. The book of Enoch talks about the portals of the sun. And it's just too much, man. It's too much evidence showing flat earth that it is glow. You cannot find curvature. Okay? You cannot find curvature. It's too much evidence out there pointing towards flat earth, and you need as many evidences as you can to prove to convince yourself that it's flat earth, because you can't say prove flat earth, because one thing doesn't prove flat earth. But you have 10 things, it's overwhelming evidence. It's guilty time. You can go to court and have one piece of evidence against you, like, that's not a shadow of a doubt. But if you got 10 witnesses or 10 evidences, your ass is going to jail. Okay, people, I am about to flip. Okay, we are in the 1, 2, 3, 4, 5, 6, 7, 8, 9. We're in my 9th portal. I started it at the beginning of this video. I put it down. I started this video right at the edge. I'm not sure if I showed it. It doesn't even matter because the time discrepancy is sick. Okay, let me go get my phone. It doesn't even really matter. This video has been going on for about 45 seconds, and it's 8:58. So I don't know if it just turned 8:58 on this clock, but I'm just showing that it's still March the 4th, Saturday, March the 4th, 8:58. And people, it's now going to take forever for this sun to cover, this sunline to cover, because let me sit back down. My window. The sun is coming through my window. It's coming through this. Okay, it's coming through the fourth window from the left. 1, 2, 3, 4. It's now coming through the fourth window. At 7:30 this morning, it was coming through this window. And then we did our experiments or whatever. But now it's in the fourth window. It's shining down through the fourth window. It's shining down through the fourth window. The sun is shining down through the fourth window. Can't really see it, but that's all right. It doesn't matter because I have my portals here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm in my 9th portal. Okay. Basically, it's coming up on 2 minutes. It's coming up on 2 minutes. You know, I got the other videos to explain it. So you watch I might connect them all together, but you can see what I'm showing here is how long it takes for the sunline to move over the ruler. Now, when I was over here in the second portal, we all saw it took 2 minutes and 35 seconds. It was halfway between the second portal, half of the ruler was in the third portal. More of the ruler was in the second portal, but it was like 3 inches, 3 1/4 inches, 3 1/3 inches was in the second portal, and then 2 2/3 inches, 2 3/4 inches was in the third portal. Okay, it took 2 minutes and 35 seconds. I'm gonna connect that video here anyway. You know, I had these papers and stuff down or whatever, but it doesn't even matter. Okay. Now, just like I was thinking about, you know, if I had a flashlight and I was standing 3 feet over a surface, okay, or let's just use a door. If I had a flashlight, this is gonna take forever. I'm gonna be able to explain it by the time it covers that. It's already 3 minutes, okay? If I had a flashlight and I shined this flashlight at this door and I moved my hand over, whatever. I'm only like 6 feet away from this door, maybe, but it would take a certain amount of time, okay? Now, if I was 300 yards away from this door and I had this flashlight and I moved it just so slightly, it would move a lot, okay? So that means if I'm farther away, if I move, because the sun is moving right now at the same speed that it was an hour ago or an hour and a half ago. So if I shine the light, at this door, if I shine a light at this door, and I'm 6 feet away from it, if I move at the rate of, 1 inch per second or whatever, it would take a certain amount of time for that light to cross over a certain line or whatever. But now, if I'm much farther away, I don't know if you can still see that. If I'm much farther away, if I move my arm at 1 inch per second, it's gonna move much more, okay? So basically what I'm showing is, in the morning time, the sun is very far away. Okay, just checking over here. The sunlight is still not over there. Okay, in the morning time, the sun is much farther away. So the angle, this is geometry, okay? Mayans, Egyptians, whatever. These windows are providing my angle of light to shine there. So when the sun is farther away in the morning, as it moves, that light is gonna move faster over there. It's moving at the same speed, it's gonna move faster. But as it gets overhead, that sunlight is moving the same speed. The sunlight's gonna move slower, so you can ponder on that. That's basically the point. It's 5 minutes, okay? I started it at the edge, okay? I started that light at the edge. You can see in the beginning of the video which side it was, but it was this side, okay? I could tell because I just know from this experiment now, this was the line that started, not this line, but this is the line that started. And it's taken well over 5.5 minutes now. The last one was 4 minutes and 20 seconds. The one before in the 7th portal 9, 8, 7 portal. 4 minutes and 20 seconds in the 7th portal. 2.5 minutes in the 2.5, the 3rd portal. Crossing over from the 2nd to the 3rd portal, almost halfway. And we can see where this line is about to, it's gonna make it there. It's almost there. It's gonna make it there. You can see 9:58. 8:58 to 9:04. That's 6 minutes, and we can go ahead and call it. Okay, 6 minutes and 15 seconds. People, it's no way the sun is 93 million miles away. You can do this experiment on your own if you have any type of window. In the morning time, you need a high window because in the morning time you can see the sun. Because if you only have a low window, I don't know if you can do this experiment this many times. But people, the sun, when it was early this morning, the sun was, if I stood right here, the sun was right here. When I stood right here at 7:30, and I could prove it, whatever, tomorrow it'll be the same place, virtually. But it was over here in this portal, okay? All right, and then when it shined through, it shined down over here. That's why I started the experiment over here. And it was at some time after 7:30, I want to say 8 o'clock. It was right here. The ruler was halfway between there, virtually. 2 minutes and 30 seconds over here. So you got 1, 2, 3, 4, 5, 6, 7. Well into the seventh. It took, just a little bit into the 7th square. It took 4 minutes and 20 seconds. Now over here was a whole 6 minutes and 15 seconds. This is in an hour time frame, people. It's an hour time frame, people. I started this experiment at 8 o'clock. It's now 9:05. People, within an hour, the sun line, this is what we're calling our sun line because it's moving. You can see it, it's moving. You know, if I stood still for like a while, you could actually see it moving because these lines on my floor helps, but this ruler helps. But this is all geometry, people. I mean, I don't see if you can see it, but to me, this is all geometry, all these angles, not this angle up there with that sunlight. No, it's the angle of the sunlight hitting the floor from my established window, immovable window here. All right, the angle, crepuscular rays, okay, shining down at an angle. And if the sun is farther away, those angles are going to be sharper, okay? And then as the sun gets closer over our head, meaning later on in the morning, closer over our head, it's only been an hour, those rays are going to be at a more of a wider angle. So it's going to take them much longer to move because it's not as sharp. See what I'm saying? Just like with the flashlight on the door, if I'm close and I move a little bit, so it's only going to move so much. But from far away and I move so much, it's going to move, if I move the same speed, it's going to move much faster. So this is the morning, being far away with the flashlight. This is the morning, and then the light moves much more. But as you get noontime, the sun is closer over you. The light doesn't move as much, so that's why it takes longer. Oh my gosh. It takes longer for our sunline to move because the sun is closer now than it was this morning to me. Now, I'm in Alabama. If somebody did this at the same time in another state, it wouldn't be the same. It's almost like localized to your address. I mean, it's crazy. But shh, people, the earth is flat. The sun is right here with us. The sun is not 93 million miles away. It doesn't make any sense. It doesn't make any sense at all. The sun is 93 million miles away, okay? Not from this experiment, not from any, it's too many flat earth experiments that prove it. I mean, not one, you're not gonna have one experiment that proves the earth is flat, okay? All right, but when you put 15 and 20 of them together, then it's common sense, okay? If the only proof you got is a Hollywood movie to the moon or a Photoshop photo of the earth, that's all you got. Or somebody going on zero gravity, you can do that. You can do that on an airplane. They got even music videos, people doing that. You can pay to do that. I mean, I can float around in an airplane too, right here on Earth. Okay, you don't have to go to space to float around. All right, green screens, those what do you call those lines where they whatever, those cable cords floating around, connected to cable cords, hopping around. I don't know, man. But all I'm saying is just from this basic experiment, I'm not saying anything else, which is my own experiment because that's all I have. I'm not basing my theory off anything I've seen or read anywhere. But my own observation shows that the sun being far away in the morning, shining its light, the sun is moving, so the angle of the light is faster, farther away. But as the sun is close to you, the angle of the light is much slower. The sunline moves much slower. The sunline moves much slower the later in the day it is on a grid or for angular measurements, whether it's going like this or it's going like that. It's going the movement of the sunline is going to differ. I'm going to let you ponder on that. I'm going to let you kind of think about that because I don't want to over explain myself. But hey, much love. Do your research.